Sorry for the slight editing thing. I just like to give you a few more examples of these, probably more than even what's here. To continue on, more examples, if you can, just plug it in. What's a number slightly to the right of -6? Slightly larger than -6. How about -5.9999999? Well, now, if that's true, if we're plugging in -5.99999999999, well, it turns out that in the denominator here, it will approach a number slightly bigger than 0. How do I know that? Well, I actually factored the denominator. That made it easier, but you can plug this in the hard way too. You can take a calculator, you can work it out on your own. You can find out that this will get closer and closer to 0 the closer we get to -6 from the right-hand side. Now we see that there's infinite limit. We have a negative sign on top, we have a positive sign on the bottom. Guess what this limit is approaching? You got it. It's not a limit, but we're going to write -infinity there to tell us that as we approach -6 from the right-hand side, this graph is going to be going down. And we probably know there's a vertical asymptote there. Okay? Very next example is almost the same, except now we're approaching the right-hand side of 4. You'll notice with the information there, wait, what's the difference? If I try and just plug this in, don't I get something to the effect of something like 0/0? That's indeterminate. What do we do for indeterminate? Well, maybe we'll factor out, maybe we'll rationalize, maybe we'll simplify a complex fraction. But we might want to look at this as, dun dun dun, hey, surprise. It wasn't an infinite limit. The limit's 1/10. The limit exists. So sometimes it may look like maybe it's an asymptote just because you have 0 in the denominator, but you know what? Use all those same old rules that we had, and if you factored out either of these, they're the same function. We know that we could divide out the x minus 4s if we really wanted to. Okay? For the next example there, guess what happens when you take a number minus or plus infinity? I don't care what's in front here. If you're adding infinity or -infinity to it, this is pretty much negligible. We know that any regular real number, if you add or subtract infinity, is going to be infinitely large or small. So don't be fooled by those. Let me give you one last set of examples. For trig limits, know thou unit circle. Goodness me, we do know that cosine of pi/2 is 0. So what happens when you're just a little bit to the right and left? Not sure how that just turned out. I use my right and left. I think it's opposite for you. Whatever. How do you know whether it's slightly positive or slightly negative, depending upon which way you're going? So let's take a look for cosine graphs. Here's what I would think about. Well, let's think about what we know about cosine. Whether you like to use the unit circle. And I would go from 0 to pi/2. So if I'm a little to the right, a little bit farther, this is pi/2, a little bit farther, is a little more this way. So I'd be a little dot there. Cosine is like your x-coordinate. Now that is very close to 0, but it's slightly on the positive side of the x values and the negative. Likewise, in the graph over here, if my dot is just a little bit past pi/2, is my dot above the x-axis, positive, or below it, negative? When I'm looking at this particular function here, I've got one over something very close to 0, but it is going to be negative. Take a second to figure out the same thing out about sine. And I just did this drawing for both of them in about 10 seconds combined. If I'm a little below 0, I think my sine value is negative. Or if I'm a little back on my x-axis,